Hi, so this is part 2 of Big Data Technologies. First of all, we've been asked to repeat the quick start guide, which I've already done. And I've started off my imply by downloading all the required packages and starting with the local host. So this was the things like cd imply and bin supervised. So it starts off implies with localhost 9095. And this is how my imply looks like. Second, the task has been add other data from sample sites. So I've used the CSV data using the URL and JSON file. So for just loading the data, I have used this FL insurance sample. This is just a random data from some website, and I've repeated all the steps that has been done in practicals to load the data and what the imply guide states. So, and I've then created a data cube for this particular data. So you can see that this has 36.63 counts, 63K counts, and these are dimensions and measures. Okay. So this is our loading data. The third part is test real-time streaming data and set up and ingest from Kafka. Again, I've repeated steps given in this guide, and this is how my Wikipedia Kafka data cube looks like. So I have installed this particular Wikipedia Kafka data and done the streaming by using the prompt and terminal. So this is Wikipedia Kafka, and if I've generated the queue, I will open this, and again, this will show these many number of events. This shows that I have already done the setup of Kafka Wikipedia. Now, the last part is that we have to visualize the dashboard. Okay, so the assignment says that we have to visualize and make something similar to this. So I've already, so this is my particular dashboard. If I open it, so this gets open, and this is my dashboard, how it looks like. So I've just taken the data from the website, and the data is called the collision Monroe country crash data. So this means that this data has particular kind of collections of collisions, which include the car collision, pedestrian collision, motorbikes and cycle collisions, and which location were the types of collision taken, how many collisions are there, what time of the day, what month, and whether it's a weekday or a weekend. So I'll just quickly explain what does this dashboard say. So first of all, I will start off with this table. So this particular table tells us the reported location, collision type, and number of collisions. So I've just made a visual of this thing. So these are all the location like E3RD, 3RD, 3RD, and Liberty. And these are the number of collisions taking place, and these are the type of collision. So we need to justify that which location is having the most number of collision taking place in that particular area. For us here, it is E3RD. So there are total 7 collisions, and the type of collisions are 2 car and pedestrian. 2 car, 1 car, 3 car are a type of different cars which have been named in the data set. So there might be a possibility that this location has these many the highest number of collisions because it must be a crowded area, or many people used to visit it, probably a recreational center, or any particular interpretation we can make. Also, this data set has a count of 667. So there are total 667 events, which I've already mentioned, but this does not come under my dashboard. My dashboard is this. Okay, next I will just start tell you by showing the sunburst. So sunburst is a kind of similarly to pie chart, but it looks like somewhat like a donut. So I have just stated the distribution of collision types. So as I told you, there are different type of collision like car, 3+ cars, pedestrian, bus, cyclist, motorcycle, and again 2 car. So this shows that how many collisions were done by these types. Okay, so maximum comes up to 2 cars. So it must be a kind of maybe second-hand car, or and see, the most collisions are done by cars only, which is very common. We know that driving cars causes some kind of collision here and there, like taking wrong turns, crossing the red light, or maybe colliding with some footpath, etc. So this justifies the reason. Next thing I would like to show again a table. So I have created one more measure in my particular dashboard. So this measure is new measure location. So this actually counts the unique location, and I have used this measure and taken out the time, day type, injury type. Time is what time the collision took place, and day type is whether it's a weekend or a weekday, how many. So the main motive of this particular table is to identify whether the maximum collision takes place on a weekend or a weekday. But our result says that it takes place on a weekend, and this number is the particular number of location. Okay, so for probably I've shown the date also, but it's the time that we see 6 to 7 a.m. So basically in this duration, most of the collision take place in 46 locations. And what are these type of locations? Are like basically it must be somewhere around the E3D, because this location has been seen in many various places, which I will show with the maximum number of collisions. But this particular table tells us about the time and weekday or weekend. And what is this? This is the type of injury. So basically when collisions happen, it is not necessary that a particular person or a particular car or a vehicle will be affected much. It might be a normal safe collision also. So this has no injury, incapacitating, and non-incapacitating. So basically no injury ones are the highest, and we see that most collisions are done on weekdays. Why weekdays? Because everyone is going to their offices, most of the people are relaxing at home on weekends, so we don't see any much kind of collisions on weekend or weekdays. And most probably that these collisions, like number of new measured location, states that these collisions were taken this number of unique locations. So 46 locations in our whole number of locations have the collisions which are done during 6 to 7 a.m. Okay, so there are a lot of locations which are helping them. So basically when we go down and down, so we have a higher number also, like for example 7 to 8 a.m. has 64 locations, because probably people, this must be some, these 64 locations must be some office area that people are going through the office, and there's a lot of traffic and all this happens. So I think this is very clear. Next thing is a bubble chart that I've made. So bubble chart usually tells us that how the data is distributed. I have chosen the location and the number of collisions in that particular location. Okay, and what are the type of locations? So this includes three things. So firstly, it includes, like for example, I'll choose this one. So third and Liberty is a location, 2 car is a type of collision, and 4 is the number of collisions that happened in that particular area in a particular day and particular hour, which is the x-axis and y-axis. So this is a very beautiful interpretation and visualization of this particular data, and it has spread across the graph very beautifully and is easy to visualize. And if you click on any of these, hover over the these bubbles, so we can see that which collision was taken how many times in which particular area and by what collision type. Okay, next is the line chart. So this is a very simple line chart that I've chosen, but I wanted to see that what are the timings on the weekend or the weekdays. So this is basically telling what is weekend, what is weekday, like how many collisions take place at this particular time on a weekday or a weekend. So for example, let's hover on to this particular point. Okay, so this is like a weekday, so there are like 56 collisions taking place on weekday on this particular date and on this particular time. And similarly for weekend there are just 3. So you know that on weekend everybody is at home around 11-12 p.m. going out for brunch or staying at home, but on a weekday by 11-12 p.m. everybody is on the roads for taking lunch, buying lunch, or probably some going to one place to another. So like this is just justifiable, and everything same for different points. So actually this is the kind of highest point. So I was explaining this particular point 57. So 8 to 9 a.m. this is like 11 to 12, the number of collisions reduced. This is 8 to 9 a.m. which is like an office time. On a weekday so many collisions happen, and on a weekend everyone is relaxing at home, so no, like very less collision happen, which is comparable. So we can see in a clear change that weekday has less collision and weekend has very more collisions. And of course it goes flat in the night because everyone is at home. Okay, now next thing, I have just made this particular tree map which shows us the types of collision, and sorry, the tree map which shows the reason of collision. Okay, so what is the reason of collision, that why did the collision happen? So these blocks which are like blue, pink, magenta, red, orange, so these particular blocks are the factors affecting the collision. For example, I'll just say about this red one. Okay, so like, or probably let's go with the blue one. Okay, so following too closely, so people who are very close or the vehicles which are very close are tend to collide on a much higher scale. Okay, so like that's why they have a big area where we have, you know, like a total number of locations. Okay, so like so this particular tree map shows that what is the reason of the collision and on which location this reason was very frequently affecting the collision. So for example, I'll just tell you about this particular one, probably purple one. Okay, so purple one. So probably a kangaroo, sorry, I'm talking about Australia, but this is Monroe country data. Probably some animal must be on the road and some car must have collided, truck must have collided, pedestrian must have fallen down by seeing them. Anything could have happened. So this particular area, this particular reason is used in these areas. So like all these areas, so probably I can just tell you that these must be some highways where the animals are passing by or crossing the road, and many of them must have collided, and the list goes on. So this particularly tells the particular reason of collision and in which all areas. These small box that you see, this are the particular areas, and in these areas how many accidents happen is the number like 1, 4, or probably 69, and everything like that. So more of that. So this is a distribution of the factor, the location, and the number of collisions. Lastly, I would like to tell you about this thing. So I've just made a whole table of the full data so that you can get a clear account and you can refer to it anytime. So what all my data consists is injury type, collision type, time, primary factor, and weekend or weekday, whatever by count. So we know already that the injury type is like, for example, no injury or incapacitating or non-incapacitating. There are different car types and what time the collision took, what is the reason of collision, and different days on like whether it happened on weekend or on a weekday, and the list goes on. This is like full data that how many collisions happened which were non-injury type. I have probably yeah, so this is more visible, like we can see that what all, like overall I said showed in the first there was 67 collision, no injury or unknown were 542, and probably we can just scroll down and see the encapsulating one, non-encapsulating ones, and we see a beautiful distribution of this table, whether it's on a weekday, whether it's on a weekend, which has already been told in the particular dashboard. And yes, more of it. So I think everything is clear. I hope the viewer likes my dashboard, and if there are any details that require clarification, I'm ready to give that. Thank you so much for your time.